Now in the previous lecture, we have seen how the insertion of a new node in double linked list works in 3 different cases. Now in this video, we will combine all these 3 cases together to create one algorithm. Now the algorithm starts with taking 2 parameters. So the first parameter is the value of the node and the second parameter is the location of the node. So this is the value that we are going to insert a new node, and this is the location identifies in which location we are going to insert a new node. Now the next thing that we are going to check that if our double linked list exists or not. So we are going to check that if head equals to null, then in this case it does not exist. We are going to terminate our algorithm. So in this case, sometimes we can use node value and create a new double linked list based on this node value, but here we are not going to use it because our aim is to explain the insertion of algorithm. So that's why I'm terminating our algorithm over here. Now the next case is if head is not null, we are going to create a new node and assign a value that comes from this parameter to it. Now then we are going to check location parameter. So if the location parameter is equal to first, then it means that we want to insert a new node at the beginning of this double linked list. So we know that when we are inserting a new node at the beginning of double linked list, the first step that we are going to do, we are going to set the previous reference of this node to null. Because in case of double linked list, previous reference of first node is always null. So that's why first we are setting it to null. Then we need to create a link between newly created node and first node. So because newly created node is going to be the first node and the first node will be the second node. So newly created node's next reference has to point to the first node. So that's why in the head we have first node now. So if we set new node.next to head, it means that we are updating the next reference of new node with the physical location of first node. Then in case of double linked list, if we are inserting a node at the beginning of the double linked list, in this case, first node's previous reference has to point to this newly created node. So in this case, if we put head.prev equals to new node, we are updating the first node's previous reference to the newly created node. Then at the end, we are going to create a link between head to this newly created node over here. Now with these 4 lines of code, we have successfully inserted a node at the beginning of double linked list. Then after doing so, we are going to terminate our algorithm over here. Now, if the location is not equal to first, then we are going to check that if it is equal to last. So if it is equal to last, then it means that we want to insert a node at the end of double linked list. Now we know that when we are inserting a node at the end of double linked list, the first step is we have to put the next reference of this node to null. Because in case of double linked list, the next reference of last node is always null. So that's why we are setting it to null. Then the next thing that we have to do, this newly created node's previous reference has to point the last node in the double linked list. Now in tail we have last node's reference, so if we set new node's previous reference to tail, we are creating backward link between newly created node and the last node in the double linked list. Then the current last node has to point to this node. We have to create forward link between them. So if we put tail.next to this new node, we are creating a link between the current last node with the newly created node. Then at the end, we have to change the tail to point to newly created node because in this case, newly created node will be the last node in our double linked list. So that's why we are setting tail to this node over here. Now with this, we have successfully inserted a node at the end of double linked list. So we are going to terminate our algorithm over here. Now one more time, we are continuing to do checking the location parameter. So if the location parameter is not equal to first, we are continuing here. If it is not equal to last, we are continuing to else condition. So in the else condition, we are inserting a node at a specified location. So this means that we need to find a node which is located before the place that we want to insert a node. So when we find that place, we are going to stop there. Then we are going to create a link between newly created node and next node. So if we set newly created node's next reference to the current node's next reference, it means that we are creating a link between newly created node and next node. Then we have to create backward link from the newly created node to current node. So we are setting the previous reference of newly created node to current node. Then next node after newly created node has to have a backward link to new node. Now in new node's next reference we have next node because here we have set it. So if we put new node.next.previous, we are accessing the next node's previous reference, and if we set it to new node, we are creating backward link between next node and newly created node. Then at the end, current node has to point to new node. We should have a forward link between them. So this means that if we set current node next reference to new node, we are creating a link between current node and newly created node. Now with this, we have successfully inserted an element at a given location in double linked list. Then we are going to terminate our algorithm. Now with this, we have finished our algorithm. So in this algorithm, we have combined 3 cases of insertion in double linked list. So in the first case, we are inserting a node at the beginning of double linked list. In the second case, we are inserting a node at the end of double linked list. And in the third case, we are inserting a node at a specified location in double linked list. Now based on this algorithm, we can easily create a method in Java which inserts a node in double linked list for a given location. So if the location will be the 0, we are going to insert at the beginning of double linked list. So if the location is greater than the size of the double linked list or equal to the size of the double linked list, then in this case we are going to insert it at the end of double linked list. So if the location is something different, which is a specific location, we are going to insert that specific location in double linked list. Now with this, we have come to the end of this lecture. So hopefully everything is clear about insertion algorithm in double linked list. Now based on this algorithm, let's create our method in the next lecture. So see you in the next lecture.